Greetings and welcome back to the lab and welcome back to the Bike Flower project. And if we're going to do the bite-size engineering thing, let's do it bite-size. Where we are with the Bike Flower project, if you're not familiar, it literally started with me looking for penny auctions. And I ended up finding the bike flowers, or the bike lamps, and they come in three different models that I've seen. There's the round one, there's the one they call the frog, and there's the one that I call a double because it's rectangular and it's got an LED on each side. So that's one of the models, and I've mapped out the schematics for these. They all have a blob chip that controls the various modes. I have listed out, actually now that I'm looking at it, I haven't listed out on the round, but I've also had to figure out if I'm going to use these, if I'm going to reuse them for the purpose of the bike flower, I need to do testing to figure out how to make the different color LEDs the same brightness. And that seems like it could be difficult unless you had complicated equipment, but I've come up with a solution that I'm hoping will work, and that is using an Arduino type light sensor, which is on this breadboard. So I can pull a piece of tape off of there. So hopefully that's going to come through. You can see that there's an LED at the end of this blue board here, and then I have another bare LED pointing right at it. And so what I do is this is the light sensor with its circuitry, and it's been tuned using that variable resistor right there. So that combined with the resistors that are on my substitution box, that helps me determine what resistance I need to achieve a particular brightness. And just to keep the studio lights and stuff from causing a problem, I'm putting a piece of tape over the LEDs, just kind of loosely. I'm not trying to make this super complicated. I could build a whole rig, but this is for one project. I might consider that for a project. If you're interested, definitely comment down below, let me know. But let me plug this in just to kind of give you an idea, just a little bit of an idea, what this looks like. And so you can see that it is, that's basically an indicator that the circuit is on. There is, let me actually pull this back off. And actually, now that I look at it, something's wrong because this is not powered up. So, oh, I know what's wrong. One of the things with these circuit boards is that they each have a switch. Depending on the circuit, they are either pulling it to ground or pulling it to the positive rail to signal the blob chip, which is basically got to be a microcontroller of some sort. That blob chip, when it gets a signal, determines where it's going. So this is my switch. It doesn't look like a switch. It's just two wires. But what is a switch but connecting two wires? So first time I connect it, I get a blinking light. Next time I connect it, I get a solid light. That is, I believe we're using that's the white circuit board there. So that is the round. So now we've got a light on. And if I want to get somewhat reliable reading, you can see I've got a second green light on there. And that is the digital. I've set it up for the digital output. That will indicate when it exceeds a threshold. So if I turn the resistance up enough, it will shut off. Now, if I actually cover this up so I can keep the light isolated from the other lights in the room, that might improve it slightly. Well, but you get the idea. So, I mean, I can keep making it brighter and brighter and brighter. And you can see it's kind of getting brighter underneath here. But the key is I want to know when does that turn on or off. And it turns off right there. So I can use that to test which color light gives me a particular brightness. So I can compare all of the different LEDs that I'm planning on using, and that should give me some results. So now let me quickly take this apart, and I'll show you what I mapped out in terms of schematics. Okay, well that was the round. You saw it flashes fast, and then it goes to solid, and then it's off. So those are the three modes. So this is a model JD584 that's on the circuit board. This is the round that we're talking about. And I mapped out the circuitry. Now, this is not a conventional schematic, but I wanted to see how everything's hooked up. I've got a positive going into the blob. I've got negative here, ground, going up through the switch, through one of the switch legs, into the blob. The blob's got an output for the LED, in this case LED 1, because there's only one LED on the round one. I've got VCC on the left and basically ground on the right, but ground through whatever control that they've got here. VCC, the reason I labeled that VCC is because you can literally put a meter across this point and that point and you will get continuity. The switches work as they're dome switches. So there's those little metal switches that you push down, and they work by connecting this leg with that leg, and coincidentally also this leg with that leg. So there's two switches on this. I guess just in case with the round one, it's got just a single lens on the top, and when you push down on it, it switches it on. So it's either one of these would cause it to switch on. They're wired up in parallel, so that's where you are. Interestingly enough, now that I look at it, the middle pin on this is actually connected on a separate line. I'm not sure if that's, maybe it does come around and they just connect at a common point underneath the blob. So, but anyway, that's what we've got there. That's the round. Now, we've got the frog, which is this one here. And this has, here's the frog, there's the blob chip, there's the switch in the same sort of configuration, but there's only one switch, which is on the top of the frog. It's got VCC in, which is connected to two 2032 batteries. Interesting. I thought I wrote down the modes for all of these. Okay, I'll get that filled in later. VCC for basically positive battery. Then you've got negative battery is, that's one pad with two holes in it. So the negative connects here, and there's a ground. There's the switch, like I was saying. When you push down the dome, it makes contact. It's going to send a negative signal to the blob. You've got VCC coming up to here and down to here. These are the positive connections for LED 1 and LED 2. And then you have a common negative here, which is controlled by the blob. So that is what you've got for this particular circuit. And then we have the double. And here's where I wrote down the modes and thought that I had done it on all of them. And then the plan is from wiring them up, I will put them on the test rig and I will change the LEDs from red to green to blue to yellow, which are the colors that I'm working with right now. So that's where we are on that. The next episode, we're going to start going through these one by one, probably starting with the round, since I've got that already wired up and ready to go. We'll test all four colors, maybe five, and we'll see at what resistance do I get the same value of brightness, and is it bright enough? I think I tuned it to be about the right brightness. That was the key, was tuning that light sensor so that it would flick that LED on when it hit the right brightness. So that's the idea, is that I can then try different resistance settings and find at what point does it change to make it bright enough. And at that point, that's the resistance that I would select so that I can put different resistors on all four colors and have them all be the same brightness. It's a lot of work going into a relatively simple project, but this is engineering. Sometimes you got to do the testing before you can start designing, because you have to know what you're dealing with, what your limitations are. So that's where we are. That's this episode. Like I said, in the next episode, we'll probably go through the results of the round and tell you what I found. Thank you so much for watching. I'm sorry about rhyming.